This is the second tape on lecture number 9. And lecture number 9 was on ATM, if you want to say, and ATM, other LANs, other than Ethernet-based, other fast LANs. And then in the first part of this lecture, we talked about FDDI and we talked about DPAM, 100 VG LAN. And in the second part, which is today, we talk about ATM LANs. And that way we are done with all the fast LANs. Now, but before I go there, I would like to make some announcements. Number one is that now that you gave in your project number 2, so we have posted project number 3. So project number 3 is like socket programming, is due to 2 weeks from now. Okay, and at the end of this lecture, I will go over the supplementary material related to that. If you go to the course documents, you have an area which is self-study unit for client-server application programming. This is help material for writing the program. Okay, that's more or less what we say today. I come back to this maybe at the end and go over that very quickly, and go over the project very quickly. But first I want to finish this lecture number 9. Lecture number 9, other fast LANs, and we started with like 100 VG LAN, then we talked about FDDI. The point that I had in the 100 VG LAN was that physical layer was more structured than like fast Ethernet, but anyways, it did not pick up. FDDI was popular for a while, for at least 5 to 10 years, but now it loses its popularity to fast Ethernet and gigabit Ethernet. But anyways, FDDI is the one that its physical layer was used in the 100 base X fast Ethernet. So what I did in here, however, while I was talking about FDDI and about 100 VG LAN, I opened a new, in fact, can of worm, which was issue of quality of service, which is a little bit different from quality of service when we were talking about 802.5 or 802.4. In 802.4 and 5, we had the so-called user priority. So you have a MAC frame. Inside the MAC frame, you have so many bits. And in those bits, you are putting like priority order. Okay. And then when we came to 100 VG LAN and FDDI, I started to introduce a different aspect of priority. That's the so-called access priority, if you want to call it. A mechanism which is inside the LAN that supports a sort of priority. Okay. And anyways, why we are interested in priorities in general, we are interested in that because there is an unsolved issue around, and that's the issue of quality of service. Issue of quality of service has two different perspectives. One is from the ATM point of view, which is from voice-oriented networks. The other one is from the data-oriented networks. And today, the whole entire industry is striving to find a solution for that. So a lot of struggles in there are around how to provide this quality of service. What is this quality of service? So then you go to the mechanism which have provided this type of differentiation, and you see where is the state of that today. Okay, so that was the thing, that's why we went over the priority schemes. A lot of these priority algorithms are needed here or there. Anyways, so based on that, this was the coverage of DPAM. It's a token. This was the priority scheme, like two wheels. One of them rotates, the other one stops, the other one rotates. And then this was the hierarchy of like repeaters and a bunch of terminals was architecture. This was like frame transmission technique. And then the interesting part was that it had 4 similar pair of wires to transmit the information. As a result, it doesn't go to trinary. It goes to binary type of communication. And then the coding was 5B6B, which was something new. And then we came to FDDI. FDDI, one of the things was interesting was that it is not inside 802.11. Sorry, 802 community. And then we talked about like architecture and how they put it together, and relationship to 802.5 and relationship to 802.100 base X, and at the end we came to the priorities. And we saw that priority scheme in here is different from priority scheme in 802.5, though both of them are token ring, because in here you release your token right away after the packet. In 802.5, you send the packet comes back, and then you reset. You send your token. As a result, you can use that mechanism and enforce a sort of priority. In here, you don't have that, so you need an automated priority scheme, which was the one that we went over in here with this example. And we went over this table, and you will do something similar to that in one of your homeworks. Okay, it's part of your homework. And then this is the place that we left last time. Asynchronous transfer mode LANs. Okay, the way that I look into the ATM in this lecture is like I'm taking ATM as a part of local area networks, really. I wanted to talk about lanes, high speed local area networks, which are using ATM. That was my objective when I prepared this lecture. But I was thinking about actually changing this lecture and make it just ATM separate, and then talk about lane as a part of that. If you want to look at that as in that context, that this is a little overview of ATM with lane as an example, then this is really does not belong in this lecture. It's a separate lecture as a part of switches and routers and bridges. Okay, so it's half and half lecture. This is lecture 9.5, if you want to call it. Separate unit, but it has part of it which is lane, which is related to local area networks. Part of it is overview of ATM, which is not related to that. This part fits very well to opening the issue of quality of service. Okay, but anyways, let's go over the ATM LANs, as I said, and first we start with an introduction of over ATM. What is ATM really? ATM is, I have made minor changes between last one and this one. I put the revised version in the web. Maybe 2-3 pages are different. So if there is material that is not in your handouts, you can print it out. Okay. Number one, if you remember before we talked about it, ATM from one side is continuation of X.25 and frame relay. If you remember, X.25 was the first like nationwide data service, which was connection based. Means that if you want to communicate between two computers, you make a telephone call. And telephone company gives you a line, and then you connect the two computers at the rate of 64 kilobit per second. Okay. X.25 started in early 1970s. At that time, internet was in infancy. So it was an independent, practical network available to who? To airline reservations, to the banks, and to anybody who wants to have a wide area network. Then later on, telephone company started to change a little bit the X.25 as we had more LANs coming into the picture. In 70s, we didn't have LANs either. We didn't have local area networks. These are in 80s that local area networks come in. When local area networks come in, now these data networks in one hand are connected to local area networks, and in between there are WANs which want to connect them. And X.25 is simply too slow. On the other hand, when you go to the LANs, they don't have acknowledgement. They don't have flow control and error control, because LANs, as we discussed earlier, are very clean environments. Okay. But when I'm making connection between the wide area network and X.25 through dial-up, that line was no good. That was not a good line. Okay. So as a result, when I had X.25, I had to have a sort of flow control and a sort of like error control. And that flow control, error control was going between the nodes and causing a lot of latency and losing the bandwidth. So now as LANs came to the picture, telephone companies started to take the lines and take flow control and the error control away, because they were not needed anymore. And by taking that delay and latency away, they could boost up the data rate to like 2 megabits per second. Okay? And that service was called frame relay. But frame relay is X.25 in a sense. It's a connection based. Just the physical line in between doesn't have flow control, error control, node by node. Okay, so that's it. So frame relay came in, and it was 2 megabits per second. Then the next step for frame relay was these local area networks are going to higher data rates. Even 2 megabits per second is no good. So now you want to go to higher data rates. How do you want to go to higher data rates? They thought about ATM. This is one end of ATM. The other end of ATM is that traditionally telephone networks, they were digital, and then in 80s again, people started to think about what? ISDN. ISDN really is a telephone connection-based service, voice-oriented, rather than the other one, which is data-oriented. This is voice-oriented. Means that they give you quality of service. They give you 64 kilobits per second, and this is yours and only yours. In X.25, different programs, they share that. They have statistical multiplexers in there, okay, which share several programs, share one line. In here, no. You have it for yourself. But in 80s, they started to think about ISDN. ISDN is like multi-rate or multi-grade service. Means that a telephone line comes to your home, rather than one telephone line, you have two telephone lines. And in addition to that, you have 16 kilobits of data. So that's the basic one. Okay. So what is the difference between that and your regular telephone? Number one is that your regular telephone is analog when it comes to your home. This is a digital service. Number two is that in addition to voice, it gives you data. This is ISDN. Okay. Now, ISDN did not become popular because telephone terminals are sold all over the place. And again, I don't know why. But it was the hype, major hype in mid-80s, early 80s. And people thought that ISDN, now that ISDN is perfect, the next step to ISDN would be ATM. And all of these things are before success of Internet, which looks for broadband. Okay, so naturally they say ISDN, next step is what? Is ATM. So when you come to around 1990, ATM standard is completed. And this need for ATM standard, which is multi-grade switches, which also supports packet switching. Okay, that's from one end. And also support voice. So it's a merger of everything. So everybody thinks that ATM is the solution, is the new unicorn. Supports everything. Okay, and ITU starts to do the standardization directly. You remember, ITU always was the end. This time there is a group actually called ATM Forum Group, which organizes these things. Actually, one of the active members of ATM Group was a fellow called Grossman, who was in Codex, and he is a WPI graduate. I used to bring him to give a lecture on ATM when, like 5, 6 years ago, when I started this type of courses. Okay, but anyways, ATM Group got together and they wanted to create this like a standard and go directly to ITU. to get their approval. Now, in late 1980s, ITU developed broadband ISDN, which is broadband type of ISDN, so wideband ISDN, as well as wide area aspects of ATM. This was so important that any other standard which was like GSM, for example, GSM starts for the wireless in early 80s. The objective of GSM is to be compatible with ISDN. Okay, so they assume that the backbone is ISDN. Okay, and so everybody thinks that the backbone is ATM. Now, then they come in 1991. At 1991, the only problem for those who are worshipping ATM is that they think that these local area networks are now used in all the offices. What do you want to do with that? And I think I went over that story before. This is my second time I'm going over that. They said, okay, there's a short period of time that local area networks are going to be there. Ethernet local area network is based on connectionless service. Okay? And then later on, it merges to Internet, popularity of Internet. Okay? At that time, still Internet is not popular. Okay? And then they become one class, which is Ethernet Internet, versus the other class, which is ATM, which if you want to call, it is like communication industry, computer communication versus telecom industry. Okay? But anyways, at that time, they thought there is no telecom industry. Sorry, there is no computer communication. Telecom industry, which is the giant, is going to get the local area networks. So what is the way to get the local area? There's a transition period that these people who have installed the LAN are going to change to ATM. So I have to find a bridge between the two. So they start to define that. And the group who starts to do that is like starting around 1991. Okay, to work on the ATM LANs. ATM LANs were perceived to support data rate up to 155 megabit per second. This is 1991. Remember, fast Ethernet is what? 1995. So these are like one of the early groups. Okay, and then they have other data rates, and they have a lot of good reasons for thinking that way. But that way thinking is based on backbone thinking. Okay, so at that time, the ATM Forum and the group which goes for the LANs, that they call them LAN emulator. Okay, now they had some stuff in their mind. Okay, and around 1992, for example, they publish a document which is shared by Apple, Sun, Xerox, all of them computer communication, and Bellcore, which is a baby Bell company. So it's a telecom industry. But it's a telecom industry which is into switching. Okay, but anyways, all of them together come up to this announcement. They have a documentation that is talking about the future of local area networks. And they divide the local area networks in these three generations at that time. First generation, legacy LANs, 802.3 and 5. At that time, 4 was out already. Okay, and then they said, okay, second generation is FDDI, which is the backbone. And then they say, okay, obviously the next generation would be ATM LANs. And there is no doubt, there is no thinking about fast Ethernet, gigabit Ethernet, etc. Now, what is the advantage of this, like ATM LAN? Why they think that this is going to take over? Okay, because they see in one hand these local area networks are going to higher data rates, but they have to become a little bit hierarchical, and they are getting in use all over the place. They are going from the offices to the homes, etc. So these are the things that they want. They think that if you want to go for the third generation, you want to guarantee the data rate. For what application? At that time, they are thinking about video conferencing. Today, after the success of Ethernet, we know that multimedia doesn't need to be really super duper. I mean, the video part We can compromise. Users compromise. We have a lot of video on the internet, and there's no quality control there. I mean, just the user end quality control. At that time, they were not thinking about that. They were thinking that this is like video, live video, very high data rate, and who can support that? You cannot support that in the Ethernet type or X.25 type. So we must to go to the other thing. The other one is support multi-rate rate. Well, that's the same, in the same line. They have these imaginary applications at that time that every person will have like video conferences every day. But the other thing which was very important at that time, they were thinking of ATM provides good scalability. Means that when you want to expand the network, people are seeing that these computer terminals are doubling every year, so they are very worried about scalability and cooperability. Okay? Like, when it goes bigger, what will happen? Definitely a structure like ATM is suited for that type of thing. And another thing which is very, very important at that time is facilitates internetworking with the WANs. So your backbone also. I mean, your backbone anyway should be somehow coming from telephone network. If everything is ATM, this is integrated. So in early 1990s, everybody is talking about end-to-end ATM as the future. The people who religiously like it at that time, in particular, is military. Military loves it because it's connection-based. Okay, and also it's very simple and military-like. Okay, very organized. So, advantages and disadvantages of the ATM LAN. The assumption was that these ATM LANs have to smoothly go inside, get merged. Means that right now everybody has a terminal and they have like an Ethernet card inside there. At that time, Ethernet cards are around $60, something like that. And now they have to replace it with ATM cards. So there should be a smooth transition in there. And then the wiring possibly may be changed, or possibly may not be changed. The other one is that if you go for the ATM, you always have quality of service, you have scalability. These are some of the things that we talked about earlier. And beyond that, they were saying that we can take this ATM and bring it on all the medias which were used for local area networks, like shielded twisted pair, unshielded twisted pair, Cat 3, 4, 5. Okay. These are the material that ATM were not used for it really generally. So they wanted to bring it in that domain. Now, ATM, another advantage of ATM at that time was for streaming. People were thinking that you have these videos and you want to distribute it like cable TV type. You want to make it digitized, and ATM is the only solution at that time, they think. And some of the problems that they had at that time was that if you want to implement like firewall on ATM switches, it's going to be more difficult. Okay, very minor issues at that time. So this is the story then. So for that reason, people wanted to go to LAN. And now what we want to do is that we want to go over this thing. For us, really, what is interesting about ATM is that ATM is still a voice-oriented network. It's a telecom type of things. And telecom industry makes much more money because they charge people based on quality of service and connection. Okay, so it's a very regulated environment. If I have a telephone network, I call, I get charged. But for the internet, I pay monthly. Okay, as a result, there's a problem in there. There's a jungle there. That jungle has to be solved. Right now, the cost that I pay monthly is much lower for the internet than what I pay for the other one. But who wants to solve? This is still a problem. Today, this is a problem. Still, this is a problem. And people try to find out a solution for that. Okay. Now, anyways, Now, what is this ATM? What is different about it? First of all, ATM is a very, very simple network. It has a bunch of switches and a bunch of end users. Okay? End users are connected with the switch through a user interface which is defined by the standard called User Network Interface, UNI. And then there is another standard to connect the switches together, which is called Network to Network Interface, which is called NINI. So there is only two standards in there, two interfaces in there. Okay, so very simple. Okay, and then the other thing is that these things which are in between, these are switches. Switches in a way that they are faster than bridges and routers, in particular from routers. For long distance, switches always compete with the routers. Routers are software devices. They get the packets which have at different lengths, they cut it, and they reassemble it in a sense. So it's slow. Switches, they don't do that, especially ATM switches. What they do, they take the fixed length, and then they have very short addresses at the beginning. They read the short address and switch it very quickly. As a result, everything is controlled. Okay, the service is controlled. And then, how do you want to connect these things together? Well, at the beginning, when I want to make the call, this is connection based. I make a call and I get my line. And then I use it, I hang up. But this is a major, actually, marketing problem. Because for data application, people don't like it. Like, if you look for example, comparing ISP providers who were selling services on the modems, okay, 56 kilobit per second, and you had to dial a little bit. And then the new broadband. Broadband, they have like 10 megabit per second, called 10 megabit per second, okay, which is shared by a lot of users, and they are not 10 megabit per second at any time. They are like 100 kilobit per second. They are very close to that, like modems that you dial up modem. I mean, the one that I have in home, I have a wireless LAN connection, and I have another like direct connection, and it's much worse than dialing. The only advantage that it has is that anytime that I want, I go at the PC and it's on. So that creating the connection, which for telephone company is good, because now they can regulate and charge more. For the users, is inconvenient. Okay, so these broadband companies these days, when they advertise, one of the advertisement points is that this is a service that is always available, doesn't need dialing. Okay, so it's the pros and cons which is in there and it still is there. Now, who wants to solve it? Anyways, so this is how it works, how ATM works. Now, what have they done beyond, like frame relay, for example? What they did in fact, in frame relay, etc., you have standard switches. So you have lines that you switch back and forth. They have added another hierarchy inside that. So you have like 2 layers, in fact, of addressing. So when you switch the big one. I thought I turned it off. So they have added another layer in there. They have a virtual path and a virtual channel. Okay. In the like X.25 or in like frame relay, you have only a virtual channel. Okay. You have one line which gets switched back and forth. In here, they have added flexibility inside that. So inside the LAN, they have you have a smaller like sizes in there. Okay. As a result, you are going to have a bunch of benefits. So basically, you have, when you create the connection, you have 2 types of address. One is the so-called virtual channel identifier, which is a bigger channel, bigger pipe. Okay, and then within that bigger pipe, you have a virtual path identifier, which is one of the parts which is inside that big one. Okay, that's the only difference really. But this one gives you flexibility to provide mix and match, provide different type of services. How does the switch work? You have just like any other switches, the packets are coming with different address and they go to the other addresses. But in here, address is two-layer address. One is the big one, big pipe. One is the address of the small pipe. So you can come from a big pipe to go to another big pipe. Okay, but on the road, all the big pipes are combined together and switched together, rather than each individual becomes switched. As a result, switching becomes faster. Okay. The other thing that they have done in here is that they have restricted the length of the packet. Okay. These are two differences that you have in here. Okay. As a result, you have faster switching. Now, what is the advantage of this VPC going to the smaller lines? Okay. It allows you to group individuals and individual and the groups. Okay, so if you have a group of people sharing the same thing, you put them in one pipe. Okay, that's one of them. Increases performance and reliability, reduces switching time, and enhances user services. What does that mean? Means that if I go to a user can tell me that I want 64 kilobit, I want 10 kilobit, okay, they can change the data rate, and then they can put tags on those data rates. They say that I want this data rate for sure, or I want this data rate based on availability. So you can define different services based on that. Okay, this control does not exist in the data-oriented networks. In here, you can create it. So I have a bunch of these VPs inside the VPs. Some of them are leftover. The ones which are left over, still I can sell them as a new service. So I'm using the network also more efficiently. So always when you have like voice, assume that you have voice. Originally, actually, that started with a system called TASI. You have like T1 carrier, which has 24 slots of voice. Okay, but not all the people are talking all the time. Okay, what do you want to do with the leftover? People did studies like in early 90s, mid 80s, PhD thesis, things like that. They did calculation. So one of my students did it. You can actually get the same 24, go to up to 30 users, and still have additional data in there. Okay. So that's the same idea that you can use in the ATM. Means that the times that people are not using the network, use it for other things. Give it for email. Okay, that's the basic concept, basic idea. Okay, then the story comes, the story of call establishment. This is a connection-oriented. So how do you want to create the thing? If I create a line, the network gives me that line, and depending on the type of service, that line should be available all the time. Okay, now, so I start first. I request the VCC to originate a virtual connection. Okay. And then this virtual connection could exist at that switch, first switch that I'm talking with. Because as soon as I send my request to the first switch, similar to the telephone network, first switch will run a routing algorithm to find out that where you want to go and who are the best people in between for you. Okay, when they run it, they may find that or they may not find it. In the telephone network, control of that is much easier because it's only 64 kilobit per second fixed. Okay, when you mix and match it, sometimes it gets provider blockage can go higher. Okay, but anyway, if you have it, that's fine. They provide it. So establish the VPC connection, yes, and then they look at, can quality of service be satisfied? The quality of service that this guy is requiring, yes, okay, make the connection. If it's no, block VCC or request more capacity. Okay, request more capacity means that run another routing algorithm with higher priority. Okay, see if you can get from the system more or block the user. Okay, and if the request granted, make the connection. If it did not, reject it. Okay, so that's the basic idea, the same thing that you have in the telephone network, just it's getting a little bit more complex. Now, if I have somebody in here which has a data email application, so he doesn't need any bandwidth really of any sort. So always it goes through and gets the connection. I have somebody in here who has a video 1 megabit per second which wants to send. This guy has a higher probability of blocking. So that's what which is decided in here. Okay. Now, what is the protocol stack for ATM? ATM basically, the physical layer, like anything else, can be over anything, over all of these OC lines that you had earlier for the different data rates on the optics. So it comes at the packet level, at the MAC layer, if you want to call it. At MAC layer, it has a fixed packet length. And then you have on top of that applications. Between the application and the ATM layer, you need to have an adaptation layer. What does this adaptation layer do? It takes the information from the top and it maps it to these ATM packets. Okay. Now, what type of things this guy has to do? Well, the higher layer may look for a connection-based service, for a connection-less service. Okay, that's one of the things. So create the control signaling in there. The other thing that you have to do is that higher layers often are coming with different packet lengths. You have to cut them, make them smaller, okay, and reassemble them at the other end. Okay, so that's what this AAL works. They have defined a bunch of AALs, ATM adaptation layers. ATM adaptation layer 1 and 2 are relatively popular. AAL number 5 is the most popular, which is used for the data applications. So if we are talking about LAN. LAN is what? Data application. LAN emulation. Everybody uses AAL 5. Okay. Then they have a bunch of other layers around here. We went over this before, but they have the user plane, which is the information. They have control plane, which is the signaling. They have management plane, which is the maintenance of the line. Okay. So these layers are all defined on the ATM. So there are a lot more details than something like Ethernet, for example, that you can go over. So as a result, the detail of ATM often is taught as a course. Okay. Now, these are the definition of these layers, the way that I told you a little bit earlier. Next issue is the traffic classes. Okay. With the ATM, you can provide variety of, services. But what you have to do, you have to classify these services. Again, this is a part of that quality of service thing. Quality of service comes with the applications originally. But when you go to the network, network should provision the application, see that what they want for the application, especially if it is a connection-based. If it's a connectionless network, that's the user who should pick up the chore of adapting itself to the network. Okay, that's the difference. So often in networking, the issue comes that complexity is in the network or complexity is in the end station. When you go to the network, this is the router, this is the bridge, this is the switch, which picks up the complexity. If you go to the end station, this is the end station. Which currently in the Ethernet, in the Internet and Ethernet, this is the end station which does that. Okay, but in ATM, which is voice oriented, they want it. Now, if they want to do it in the ATM now, what they have to do? they have to define a bunch of services. The way that they define the services, they divide them in real-time and non-real-time. For real-time, they have two types of services. Constant bitrate. Example like voice, example like video. Okay, so if you want to make a telephone call, they give you 64 kilobit per second. If you want to make a video, you give the data rate of that video. Okay, and then they give you that one. This is constant bit rate. It's very good for what? Audio streaming, for example. And for conferences, video conferences, two-way conferences. But this is not the only thing that they need. They need another thing. That's variable rate. Variable rate services for real-time are services for which you are using compressed video or audio. See, you have video and audio are the most time-sensitive part of the information. Video and audio, however, goes either uncoded, like PCM. Okay, in the PCM, in the telephone network, you have a fixed data rate associated to each channel, which is 64 kilobit per second. If you go to GSM, for example, which is the cellular system in Europe, they take that 64, they code it to 13 kilobit per second. It's compressed, but it still is constant bit rate. Okay? But there are a lot of, in fact, compression techniques which are not constant. Like compression rate, which is used in what? CDMA. In Qualcomm CDMA. Okay? They have variable rate. The data rate changes. Okay? The same is for the video. You have fixed and variable rate videos, compression techniques. If you have fixed compression technique, they have to provide you a service that they call it CBR, constant bit rate. Okay? But if you have variable rate, means that when you're moving around a lot, okay, the higher data rate. If you don't move, lower data rate. For that type of thing, you have variable bit rate, real-time information. Okay? So these are two classes. The first two classes for real-time. Okay? Then they have non-real-time. For non-real-time services, basically you're talking about the places in non-real-time that you're not time-sensitive, delay-sensitive, in fact, if you want to call it. Packets of voice and packets of video, if they don't arrive in certain amount of time with respect to their next packet, they discard them. They are not useful. Okay? We discussed that before. Okay? Now, if you come to the data, data can have a lot of delay in between. Okay? So, the second class is that. It's supporting those type of things. But in the data, you cannot drop the data. You don't want to drop the data. Okay? You want to have accurate, but you're not sensitive to the delay. So, these are the three services that they provide for that. One of them is variable bit rate, that for the type of data that response is in a sense somehow critical. For example, in airline reservation, in banking transactions, a customer is sitting in there and the person is typing. Delay is not as important as it is for 100 milliseconds for the voice. Okay, it's not as sensitive as 100 milliseconds. But if it is more than a second or so, people are sensitive. So this is the service related to that. VBR. Okay, VBR in here is for those type of applications. Then there are cases that you have a service that at least you want, on the average, you have something. Like when you want to do FTP or something like that. I mean, on the average, you have an average and you have a maximum. You don't want to FTP something with a rate of 10 kilobit per second. Okay? For that type of services, they have ABR. ABR is available bit rate. Okay? So, available with a minimum and with a peak requirement. Okay? So, your data rate doesn't go below a minimum, below a peak. So, on the average, you have a good quality. And then you have like unspecified bit rate. Unspecified bit rate, they go for something like email, messaging, in general messages. If I want to send a message from a place to place, If it even arrives 10 minutes later, there is no problem. So delay is not an issue at all. So that's the one that they have for the third services. So this is one classification of quality of services in 5 rings, which are subscribed by what? By ATM Forum. Okay. We will see other things next week when we talk more about quality of service. This is like those AALs that I told you related to these services. So there are 5 services in there. Okay. 3 of them are what? 3 of them are time-bounded, 2 of them are not. Okay. Now I have this AAL, which is ATM Adaptation Layer. Okay. ATM Adaptation Layers, there is AAL1, AAL2, and AAL5. Okay. AAL1, 2, 5. 5 is the one which supports everything. All over, all the applications. Okay. AAL1 is for circuit emulation, ISDN, voice over ATM. AAL2 is for variable bitrate, voice and video. These 2 are only for voice and video. This is the one for data. And then AAL3 and 4 are for general data services. But the one that they use in LAN is this one, because they are talking about multimedia LANs. This is the packet format of the ATM. You have seen that, most probably all of you, many times here and there. Okay, they have some flow control, and then they have like 16-bit of virtual path identifier, 16 bits of virtual channel identifier, 2 layers. Okay, sorry, 8 bits and 8 bits. So the total is 16 bits of addressing, compared with 32 bits of addressing for IP version 4, and with 48 bits of addressing for what? For the LANs. Okay, and then the packet length is 48 octet, and the total is 53 octet. Okay, so this is the packets that you're using for the UNI, and these are the packets that you're using for NINI. See, when you go between the switches, you don't need as much detail as you need between the user and switches. That's not only for the switches, it holds for the bridges, routers, for the routers too. If a router comes to your place, comes to the terminal, it should know the MAC of the terminal, for example. Okay, but when the router goes to talk with another router, doesn't talk about the MACs anymore, MAC addresses anymore. Okay, so there is always a difference between UNI and NINI, and that's what they have in here, with a slight changes in what they have in here. Now, yes.
On the slide, when we'll move from, when the packet moves from UNI to NNI, these virtual path identifiers would hold, and virtual channel identifiers would hold only relevance with regard to that segment.
They change the segment.
That segment. So even if we lose that information, it's not detrimental to the overall flow.
That's true. So for any, like, you go the first time you go to the first VC, first 2 address segments, to the first switch, then this switch will address the next switch, and the next switch will address the next switch, and then they go all the way. Okay, and then they have a table in there, which is a fixed table, which is established at the beginning when you made your telephone call. Okay. Now, so now that was more or less about as much as I wanted to say for ATM for this course. So the issue was the packet length is fixed, and the other issue is that they have variety of services which can be provided to the user. Okay. Service classes. We don't have anything like that in the Ethernet or in anything else. Okay. That network is cooperating with the end to provide that type of service end to end. Up to now we had priorities for local area networks, which was working end to end only within the local area network. Okay. And even those priorities, network was not guaranteeing those priorities. Okay, that was like a mechanism that was relative. So if I go to 802.5 and my priority 6 doesn't mean that at priority 6 I get certain data rate. Okay, if I mark priorities 5, I get certain data. But in ATM, I provide that. So there's a cooperation between the user and the network to guarantee certain services. That they call it quality of service. Okay. Then, now let's go for the applications of the ATM. Application of the ATM in the backbone. One of the early applications of the ATM was for the backbones. Backbones of local area network. I'm talking about ATM application, not voice applications. ATM application in the data environment. So we have these local area networks in here, here, here. That's WPI in 1992-3. Okay? And they used to have an FDDI for the backbone. Now ATM switches become popular. They actually buy, I think they purchased 4 of them. The same number that we have in here. So you have like 4 ATM rather than FDDI, which was in the backbone. And they connect them with that. And then from one of these ATMs, you connect yourself to the outside as well. Okay. Now, so that's one, the backbone, local area backbone. Up to 1995, that was like that. ATM LAN hubs. So this is a very popular. Actually, in my lab, I had this thing very similar to that. This switch that we had a switch and a router in the lab, and in there we had one card which was ATM port, and then a bunch of other cards which are Ethernet, FDDI, or whatever else. Okay, so all the terminals are coming. Each of them have a card, and you have an ATM at the end to go back to that ATM. When you go to that back ATM, now you can go to ATM hubs and use the ATM backbone all the way to wherever you want to go. Okay, but the problem is that wherever that I want to go in here is that I want to go to internet. And internet is not connected to ATM. It's connected to routers. So as a result, this becomes like this imagination that everything becomes ATM did not work actually. Did not work the way that it. Another way of using ATM switches is that you have terminals this time, and these terminals have ATM cards in them. Okay? So now you have to have ATM applications. When I have Ethernet cards, I have Ethernet-related application. So all my Windows are talking with that. All the software that I'm using on my terminal are talking with that Ethernet. Now, if I change them to an ATM card, all those software have to talk with the Ethernet card, with the ATM card. Meanwhile, the ATM card is at the beginning, is more expensive. So it doesn't work. It didn't work, actually. The same way that ISDN didn't work, because people had already bought telephone and they had the telephone in their home. But anyways, when they were envisioning the thing, they were envisioning that gradually people are going to develop ATM application, and then the ATM get connected to a switch, and then they create a local area network like that. But these are all ATM local area network. Anyways, that was about like 3 applications in the backbone. Now going back to the LAN. LAN, I talked about LAN one time earlier. I go over that one more time. The basic issue in the LAN that I like, and I think it's very educational, is it will enlighten you with an example how to go from a connection-based to a connectionless network, or how you can use a connection-based backbone to support a connectionless service. Okay, basically, I have these like writings about these things. Forget it. Come to here. Connection versus connection. Connectionless versus connection-based. One more time comparison. In the connection-based, which is like circuit switch, virtual circuits. This is ATM. Virtual circuit subnet. Datagram is internet. So comparison between internet and ATM. In ATM, you need to have a circuit set up. Okay? In the internet, you don't need connection. The next one is that for the addressing, each packet in the internet has the source and destination address. But when you come in here, in the ATM, it's not like that. you always have only the next router address. Okay? As a result, addresses are short and switching is faster. Number 3 is state information. Router does not know anything about the connection. In here, each virtual connection requires a router table, a space per connection, just to control the connection. Okay. Routing itself, each packet is routed independently. Route is chosen by the VC for all the packets. At the beginning, the first router decides on that. Effects of router failure. In here, if one router is gone, no problem. The path is fine with the others. Okay? And if you remember, we said that that was the original interest of DARPA in packet switching and designing of the routers. If you hit one of them, the rest is working. But in here, if virtual circuit gets broken, you're out of it. You have to reestablish the car. Now, quality of service. Providing quality of service in datagram, in internet, is not impossible, it's challenging. Quality of service, if you want to be provided in the ATM, is available, but again, is challenging. Okay. Congestion control is very difficult in datagram, in internet, but it is easier if you have like ATM switch. So that's the, more or less, that's a summary of a lot of discussions that we have had before, and this is involved in the previous 2-3 slides. What we want to talk about right now is getting away from ATM and use ATM in the so-called LAN emulation. Okay. So the first one is this LAN emulation configuration. You have these switches in the back, which are all ATM switches, and you assume everywhere in the world is ATM now. Okay. And then other WANs are coming to the ATM also. Okay. And then you have ATM attached servers. This server is running applications over ATM. And then you have a bunch of LANs. You have a LAN in here, which is a token ring. You have an Ethernet in here. You have an Ethernet in here. You have another Ethernet in here. Another token ring in here. Token ring. And these guys have been spread among the offices. And you want to connect them to this successful ATM switch hierarchy, which is taking over. Okay. So what do you want to do? What you have to do is that you have to come in each of these boxes, which are switches that I have in here, and just the switches in here, 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 and try to make some simple, small changes. Small changes always are provided with software. Okay, so you want to put like a sort of a small software to change this thing, so that these guys can talk with the ATM backbone. That software in there is the LAN software. Okay, so this is the solution that ATM Forum comes to. Okay, so they design a software and they fit it somewhere in the protocol hierarchy so that these guys can talk with one another. Okay, so LANs can talk with the ATM. Okay, but are they going to solve all the problems? Answer is no. Because there are a bunch of features which are for the LANs that does not exist in the ATM, and there are some characteristics of ATM which does not exist in here. Okay, what are those characteristics? What are those stories? The stories is that in the LANs I have broadcast multicast. I cannot have broadcast multicast in wide areas. Okay, but even if I have local area, in local area I have like ATM LANs, they have to support broadcast, multicast. When I go to the routers, I don't have broadcast multicast either, because you cannot have it in the wide areas. Okay, but in here the issue is that I have two LANs. One is ATM LAN, and one is like Ethernet. Okay, if they want to connect in local, they should have a sort of like. The other issue is the issue of connection based versus connectionless. In the LANs, when I have a packet, this packet has the beginning and then the address. source and destination. I put it in and it goes. Okay? But when it comes to the ATM, hits the ATM network, it should create a call establishment in there. How do I do that call establishment? There is an address conversion, which could be easy as a part of somewhere, but it's more difficult than that. Okay? So how do they handle that? That handling, we went over that briefly before, but now we go a little bit patiently over that. Now, bottom line is that I have two terminals. One is at one end, which is connected to a LAN, and then at another end I have another one which is connected to ATM network. Both of them are running applications which are for what? For the Ethernet and IP. Okay, so they are running over TCP/IP. This guy is running TCP/IP. Okay, application over TCP/IP. This guy is running application over, because it's popular. All the LANs have that. Okay, everybody is using the TCP/IP application. Okay, so then what should I do to connect them? Okay, in this end I have a server which is connected with the ATM. On top of it comes from the TCP to LLC, which is 802.11. After LLC, I go to the LAN emulation software. LAN emulation software is sort of gets the MAC layer information and send it to ALL5 and ATM. These three together will be my MAC. And then goes to the physical layer and goes to the ATM network. Goes over the ATM networks all the way until it comes to this bridge. When it comes to the bridge, again goes to physical, ATM, AAL5, and LAN emulation software. This LAN emulation software will, for example, one of the major changes in here would be like fragmentation. Okay? Because the ATM packets are like 53 bytes, but LANs up to 1500 bytes. Okay? So they cut them into the pieces and then reassemble them in here. Okay? Reassemble them, pack it to the bridge, and then now it's back into like local area network environment and comes to the application in here. Okay, so this is what it does. This is a simple one. In here, doesn't have broadcasting, doesn't have anything else. So these two are communicating throughout that. Now, but in order to solve the problems, as I said earlier, now you need to have like a new interface, LAN user network interface, which they call it LUNI. This is the standard which is developed to interoperate between ATM and legacy LANs. Okay, what does it do? LUNI protocol allows ATM switches and LANs to change information. Okay, LAN works at the MAC and enables legacy LANs to run over ATM with no modification to application. So the application is the application on the LAN and comes and works on the ATM switches. LAN will allow legacy LANs to connect to each other as well as ATM LANs attached to the services. Means that if I have an ATM terminal, it can also talk with what? With the Ethernet type of application. Okay, so I have one terminal which is running an application based on ATM and wants to talk with another terminal which is running an application based on Ethernet. That's the tough one. The one that I had in here, it was not. Both of them were running application over TCP/IP. Okay. Now, how do you do that? Concept of the LAN basically is that, since I'm under pressure for time, I go a little bit faster. Basic concept of the ATM is this thing, that LAN is here, that we discussed that earlier. Okay. For the LAN, what you do is that you are going to have like two sides. One is a client in this side, and the other one is client at the other side. This client, each of them are running a LEC, LAN emulation client. They are called LAN emulation client. Okay, LAN emulation client and another LAN emulation client, and they want to communicate through the ATM network. Okay, ATM network is connection based. These guys are connectionless. Okay, how do you want to connect them? You have to have a bunch of additional servers in there. Basically, they define 3 servers, as we discussed earlier. One of the servers is the so-called LAN emulation configuration server. The other one is LAN emulation server. The other one is broadcast and unknown server. Now, what they do is that this guy is like 1-800 number. Okay. As soon as your client, LEC, wants to communicate with another person, comes to LEC to find out who is going to be the address that this guy has to talk with in order to establish a connection between these two inside the ATM network. And that person happens to be another server, which is the LEC. Okay, so first you go to the 800 number, which is general. You get the address of your local transfer server. Okay, this is the local transfer server. Then you communicate with this guy. If you are unicast, this guy calls for you on behalf of you to the other end, establishes this connection, and you send your information. So you have a connection-based service in between, but at the end you have connectionless. As soon as it's finished, you close it. Okay. Now, what if you have like broadcast or multicast? For broadcast and multicast, you have another server. This is called bus. And this bus, what it does is that it creates multiple connections, sends the broadcast message, then it closes the connection. So more or less, this is how they implement the lane over that. Okay. More details about the lane are in here that I think more or less I went over them. The last but not the least thing that I want to talk about in the lanes is what happened to the packets. Packets of 802.3 are coming in. Packets of 802.3, if you remember, has preamble, okay, which was for synchronization. A start of delimiter, which was for synchronization. Those things, you don't need them in the ATM network. So you wipe those things out. Then at the end of the packets, you had error correcting codes. Okay? You remember at the end, you had the frame check sequence. So you wipe that one out too, because this is a very reliable network. ATM network doesn't make errors. Okay? And then you take the rest of the things, which is what? Destination address, source address, length of the field, and the packet data unit. Then you add a LAN emulator header on top of that, and this is your new packet, which gets fragmented and sent over the network. Okay. How about 802.5? For 802.5, very similar. You delete the FCS, which is the codes at the end, error correcting codes. You delete the end of the delimiter, you delete frame status, and then you add the 2-byte header. Okay, so this is your new packet that gets fragmented and sent over the network. So more or less that's how it works. Okay, over that one. And with this is a comparison of different high-speed LANs. Basically, ATM LANs, I think all of them, they work in the same areas, but ATM LANs are the ones that, among the 3 of them actually, FDDI, ATM, and TPAM, all 3 of them didn't become popular. That's the bottom line. And fast Ethernet survived. Okay. In terms of distance that they cover, this is very, very important. The one which survived covers only 400 meters, but FDDI goes up to 200 kilometers, ATM goes unlimited, and DPAM goes up to 12 kilometers. Okay, that's very interesting. The rest of the material are very similar, really. Similar data rates, but the one which covers the smaller distance is the one which survived. Now, these are future directions, and basically, among the issues that people are thinking about, were thinking about actually, when they were thinking about ATM, because right now is that future. Interoperability was important, scalability was important. Tetherness is the issue which is now becoming more and more important. So these issues of scalability, interoperability, multimedia in demand, and those type of things are now overshadowed by mobility. Okay, so mobility is the thing which is more popular these days. Service providers at that time and even right now, everybody is looking for customer of one. They want to make everybody customer of one person. But as they are thinking about that, we have more and more people that we are subscribing to. Okay, but the policy of the companies is customer of one for the past 10 years. So that's more or less about the ATM, what I wanted to say. The last thing that I want to tell you right now is to go very quickly over the structure of this self-study unit on client-server applications in the next 4 minutes. Not much of time left. So these are like basically 3 lectures. One lecture is prepared by Professor Michael Konavis at Columbia University. This is the core of everything. It's a very simple overview of the client-server applications. So this tutorial comes, but what is the socket, and then it operates on the IP, and then the 2 type of connection that you can create with that. One of them is like connection based or connection oriented protocol like a TCP, and the other one is that you can use like UDP on top of that. Okay, and then there are a bunch of instructions for that, and he goes over the instructions one by one. Okay, now this is like variety of examples and the instructions that you can use. So write and read and receive sense. Basically, everything comes with this chart and the things which are needed. If you want to establish a connection-oriented protocol, you have a socket, you have to bind it, then you have to listen. And then at the other end, in the client side, you have the socket prepared, then it calls for connection. When the connection comes in here, it gets accepted, then you start to write and read back and forth and transfer data. Now, this is another, in fact, thing which is like connectionless protocol. For the connectionless protocol, you don't need this part of connection. So you send the information back and forth in there. Now, in order to implement these things, you have the socket program in both sides, at the client and at the server. And I'm pretty sure that all of you have had these things in the undergraduate in a sort here and there. Okay. Now, then there are a bunch of instructions actually, and interpretation of the instruction. This is the first one, the first, in fact, tutorial. The second tutorial, that's the best one actually. And then the second one is the one which is prepared by Sidesh. Sidesh was my TA this summer. He was, and I asked him to prepare something, help, and this is his help. Okay, it's very similar to the top one, but he has a little bit more detail in there. Okay, and the last one is Professor Sonar. When he was teaching this course, he just created a bunch of links. Actually, this one is the same link as the first one that I have, and he has more, like 3 more in there, which you can take advantage if you want to read more in this area. Now, more or less, this is your backup for doing your project number 3. Okay, and project number 3 description is in here. Okay, so basically what they want to do is that they want to create a client-server application that you write certain things in one of them, and then you see it in the other one and the first one. Okay, and then you want to close that connection. That's all for this particular actually project. And you have 2 weeks to do this project. And for those of you who have not done programming, it's better to start it a little bit quicker. Okay, and if you have questions and things like that, you can send an email to the helps in the, either Jinrong or Sumit, the TAs. They will help you on that. Okay, so thank you so much.